Alright, so I'm Joe Jaworski. I'm Director of Global Alliances and Solution Marketing for QLogic. So I'm responsible for the ecosystem that surrounds our HPC products, and then taking those partnerships that we develop in that ecosystem, bring them together into solutions that we then help to move through our server vendors such as Dell, HP, and IBM into the marketplace. Essentially what QLogic provides is high-speed interconnects for storage and for processor or server-to-server communication. And as you look at HPC, it's really the server-to-server communication product set within QLogic that we're promoting here at Supercomputing 2010. So that high-performance interconnect for servers is built on a technology called InfiniBand. And InfiniBand today runs at a very high bandwidth of 40 gigabits per second, but more importantly, it's extremely low latency. And that low latency allows those servers to communicate very fast. And our differentiation in the marketplace versus some of the other players is we designed our InfiniBand products about the mid-2000 timeframe. It was at that point in time that InfiniBand had found its focus and its niche in high-performance computing. When InfiniBand was originally spec'd and designed, it was spec'd to be the data center backbone replacement for Ethernet. So it's going to replace fiber channel, and it was going to replace Ethernet within inside the data center. And because of that, there was a lot of it has a rich set of features and capabilities that have nothing to do with high-performance computing. So some of the other vendors designed at that point in time and then retrofitted the HPC protocol called MPI on top, where our stuff was designed from the very beginning to do that. So even though we have very high or very fast latency, very low latency and high bandwidth, we also have an extremely high messaging rate. So when you look at a cluster and you divide a problem up over that cluster and start running it, and the nodes are communicating back and forth, there's a lot of messaging going back and forth. So the more messages that you can drive through from the host through the fabric to all of the other nodes means the application will run faster, and more importantly, it's scalable. So it's scalable messaging rate. So our design allows it to scale extremely high and so forth. And in fact, we will have here at our booth at 3 o'clock tomorrow at Lawrence Livermore National Labs presenting a deployment they did around our technology that is now the highest performing by an order of magnitude cluster, both for classified and unclassified. So, do you want me to go on to cloud? Alright, so now HPC is starting to move into the cloud space. There's, as you know, there's two types of clouds. There's typically those that are inside an organization and those that are servicing multiple organizations. And essentially, let's start with the cloud inside an organization. It's typically, so as an example, a university will consolidate a number of clusters together and so forth for management and security and whatever, and use it, allowed to be used by all of the different departments within the university. So you have different types of users coming in, different types of applications coming in, and that's the basis of it. So we have been working with companies like Adaptive Computing and Platform Computing. They have cloud infrastructure tools and so forth. And very specifically, a set of their tools that I'd like to focus on is the schedulers. So the schedulers take those users' jobs coming in, place them on the fabric, when they run, then after they're done, they make sure that they're moved off and more jobs are put on. So we've worked with both of those companies, and we have a capability on our fabric of offering a quality of service features. So it's set up as basically partitions of different qualities of service. So when you have multiple jobs coming in from these users, some are going to be more important than others. Well, the scheduler in the past had no idea about the partitions and the quality of service, and now it it does understand that, so it can place these applications into the appropriate quality of service. So it's a more effective way to manage that cluster, that multi-user cluster. And so that works very effectively internally. Now if you go externally, that the problem even becomes more complex, because people now can actually pay for a different quality of service and so forth. So that by this combination and cross-integration of technologies, we can offer to those cloud implementations the ability not only to host multiple jobs, but offer for those that are willing to pay more a better quality of service or higher quality of service than those that may want to pay a medium price or a low price.